Now we're going to do number 18. A company is constructing an open-top, square-based, rectangular middle tank that will have a volume of 74.5 cubic feet. What dimensions yield the minimum surface area? Alright, let's start by visualizing the situation here. We're trying to construct an open top middle tank, and so we want it to have a volume V of 74.5 cubic feet. And we're trying to minimize the surface area, S. So let's label our sides. The base is supposed to be a square, so all the sides on the base are the same. We'll just call them B. The height we're going to call H. And so the surface area as a formula would be the area of the base, which is B squared, since it's a square, plus the area of the four sides. Each side has area of length times width, which would be B times H, and there are 4 of them. So that gives us the surface area for all 4 sides. All 4 sides and the base, in other words. Okay, now the volume formula here is usually length times width times height. But for us, since the length and width are the same, that would be B, B, and H. So the volume is B squared H. And we need to now optimize the surface area formula. Well, first thing we're going to do is write it in terms of one variable. So we're going to solve, first off, volume B squared H for H. Notice, however, our V is the 74.5, so we'll have 74.5 equals B squared H. If we divide out the B squared, we'll have H is equal to 74.5 all over B squared. And what we're going to do is substitute for H in the surface area formula. That way it can be written in terms of the B variable alone. So that gives us S is equal to B squared plus 4B times 74.5 all over B squared. This reduces by one factor of B. We then have S is equal to B squared plus, and I multiply the 7 times this, the 4 times the 74.5 to get 298 divided by B. Okay, so here's what we're going to do. We're going to find S prime, the derivative, and solve S prime equal to 0 in order to determine the optimal value. So S prime would be, well, first off, let's consider our S as B squared plus 298 times B to the negative 1. So that when we take the derivative, we'll have S prime is 2B minus 298B to the negative second power, or 2B minus 298 over B squared. So now we're going to solve that derivative for 0. And that'll help us find the optimal value for the dimensions. To solve this kind of thing for 0, I'm going to multiply both sides by B squared. Distribute this into the parentheses. This will cancel out the denominator. This side will still be 0, and you'll have 0 equals 2B to the third minus 298. Now we'll continue to solve for B. That'll be 2B to the third equals 298, or B to the third equals 149. We then take the cube root to solve for B, and B cubed will be approximately 5.3 feet. Or sorry, B will be approximately 5.3 feet. So we're going to assume that for time considerations on this question, we're just going to make the assumption that s equals to 0 gives the optimal value. Optimal value when solved. Okay, so that is the optimal value for the base to give the minimal surface area. So now we're going to find what the dimension for the h has to be. Up above we had solved for h to get 74.5 all over b squared. So now that we have b, we can plug that in, 74.5 divided by 5.3 to the second power. And if you run the numbers, that comes out to be approximately 2.7 feet. So our dimensions here for optimal surface area turn out to be 5.3 feet by 5.3 feet by 2.7 feet.